Thank you all for coming. Last talk of the day. I appreciate you all sticking around. I'm going to be talking a bit about Kotlin, what it is, how it compiles, and how we can take advantage of that to learn a bit more about some of the different language features. Who here has already worked with Kotlin before? Okay, cool. We have like half and half. This will be fun. So, like I said, I'm going to be talking about Kotlin. A quick note before I get started, I do have the slides tweeted out if you either want to follow along or reference them later. Just so you know ahead of time, my Twitter handle is ttgonda, so you can find that. A little bit about me. I am a software developer at Collective Idea. We are a consulting company based in Holland, Michigan. We do a lot of different things. We create custom software solutions for companies big and small from coast to coast. It's a lot of fun to get to do a lot of different things. These days I've primarily been doing Android, which has been great, also why I'm at this conference. And then right now I'm currently based in Chicago. And then after inspiration from Corey's talk, my creative outlet is dancing. I like doing ballet and tap dancing. So Kotlin, you may have heard of it. That's might be why you're here in this talk. When I first heard about it, I was just curious, knew nothing about what I was getting myself into, but I was excited to try it out. I like learning about different programming languages, so when the Android lead came up and was like, hey, we're going to do this Kotlin thing, I was like, sure, sounds like fun. I want to learn about it. And even though I didn't have very much of an idea going into it, I came out rather impressed, and now I would use Kotlin over Java any day. So, what is Kotlin? On the website, it is described as a statically typed programming language for modern platform applications. It targets the JVM, Android, JavaScript, and native. But today, we're just going to focus on the JVM. So let's pick this apart a little bit more to understand what we're dealing with. It's statically typed, which means we get the same type safety that we do in Java. This also means that we get the same autocomplete, and we have that great IDE support. What makes the type system a little bit different is that it can be inferred. So if it's clear what type something is, we don't have to specify it. So here in the Java example, we have to explicitly say that this name variable is a string. Where with the Kotlin, it's clear that it's a string. We're assigning the string Victoria to it. So it just infers that the type of this variable is string. What else is different about the type system is that null safety is built into the type system. The nullable and non-null annotations can only get you so far. With nullability built into the type system, the compiler forces us to check for null, and it just won't compile if we don't, if something could be null and we don't check for it. This means we run a much lower risk for null pointer exceptions, which I enjoy. I never like running into null pointer exceptions. If you're running just pure Kotlin, you don't have to worry about them at all. But if you are interfacing with Java, because it is interoperable, you do still have to watch out there because Java does not enforce the same nullable types. Some other goodies that I enjoy about it are the boilerplate reductions and the functional language features. If you haven't heard, Kotlin is much more concise than Java, but it's compact in a good way. It's not necessarily terse the way some other languages can be written, making it unreadable. And with any language, you can still write Kotlin in a way that it's not the most understandable, but you'll find many ways that Kotlin is delightfully concise. It's also developed by JetBrains, so right from the start, we have great tooling inside of our IDE. And then, as of I/O, it's also supported by Google for use on Android. And then, it's a language for the JVM. It targets JavaScript and native as well, but what we care about here in this talk is the Java virtual machine. Kotlin is completely interoperable with Java. Nearly seamlessly, you can call them from each other within the same program. So you can call Java from your Kotlin and Kotlin from your Java with pretty much no issues. They both compile down to bytecode for the JVM to run. And then anything that consumes bytecode, whether you're running it directly on the JVM or running it through DEX, you can use it just the same way as you would with anything else that generates bytecode, and it doesn't care if you generate it from Kotlin or from Java. Which brings us to the main point of this talk. Because Kotlin compiles down to bytecode, we can decompile it into Java. And there's a really easy way to do this with IntelliJ or Android Studio. They provide tools for this. To start off with, they have a bytecode viewer. To find this, you can go to Menu, Tools, Kotlin, Show Kotlin Bytecode, or you can just search for the action, Command-Shift-A, for Show Kotlin Bytecode. There will be all of the bytecode that's generated from your Kotlin file. And then there's also this big button, Decompile It. You just click that, and then you have your equivalent Java file to your Kotlin code. But why would we want to do this? I started out just out of curiosity. I found out that there was this decompile button. I figured I'd see what it did, find out what the result was if I did decompile some of this bytecode. And it was a lot of fun. I enjoyed it. But I also learned a lot. There was a lot of discovery. I was able to more deeply understand some of the different Kotlin language features. And then it can also be used to find out some performance or size implications of the Kotlin that you're writing. So today we're going to look at some examples of some Kotlin language features decompiled into Java. We're going to look at data classes, destructuring class declarations, companion objects, null safety, and lambdas. This is in no way an extensive list. There are so many other things that you can look at using the decompiler. This is just what we're going to look over today. So let's start at the top. Let's look at a Kotlin class. Let's look at a cupcake class. So we have this simple class. It's called cupcake. And then we have two properties on it. We have flavor and icing. Flavor is marked with val, which is making it immutable. And then icing is marked with var, making it mutable. So after this class is created, the flavor of the cupcake can never change, but we can change the icing. If we put the wrong icing on it, we can scrape the ice cream off and put some new icing on there. And then they're both strings, but flavor is just a regular string. It cannot be null. And then for icing, we have this string question mark. That question mark makes it nullable. So we might not have any icing at all. So already we can see that this is clear, it's concise, with just the information we need. But what does this all mean? What does it mean to have these properties? Let's decompile the bytecode generated from this and find out. And this is the whole file that you get. At the top, there's some imports. That's pretty straightforward. Then there's some metadata. That's like all of the orange towards the top. The metadata is used by IntelliJ and Kotlin extensions to get some more type safety that we might not get with just Java. In the future, I'm going to omit those imports in the metadata, and we're just going to look at the body of the class or the function or whatever we're looking at. So here's the cupcake class that we're going to look at. Let's step through it piece by piece so we understand what is here. To start off with, we have the public final class cupcake. Kotlin classes are all final by default, so you can't extend them. If you need to be able to extend them, you have to mark them with the open keyword. And then we have our fields. They're both private by default. And then flavor, which we wanted to be immutable, is marked with final. Also notice that we have our not null and nullable annotations. And then we automatically have our getters and our setters. For flavor, we only have a getter because it's immutable. And then for icing, we have both a getter and a setter because that one is mutable. And then also notice the not null and nullable annotations. You'll keep seeing those everywhere. And then we have our constructor. Takes in a flavor and icing and assign those parameters to those fields. Also notice that there's this check parameter is not null. Now, if you're working with just Kotlin, you have the null safety built into the type system. But if you're calling Kotlin from your Java code, Java is not going to enforce that type safety. So Kotlin favors safety in this case and does this check for you and will point you directly to what's null that shouldn't be right at the start. And you may be wondering about the performance implications of this. There's an extra call in there. You might not want that. But overall, there isn't much of a performance loss for this. This is a benchmark that was given by Duncan McGregor at Kotlin Conf. You can see that there's hardly any difference in those bars. If you want more information about that, check out the recording of this talk when it's up. I won't look over too many of the benchmarks in this talk, but the TLDR is the most part with normal use. There isn't any issues that you need to be worried about. That extra call's just keeping you safe. It's not going to cause you any issues. All right, so we looked at a simple class, but we can also have a data class. We make something a data class by just adding this data keyword at the beginning of the class declaration. Now, I could go through and describe to you what it means to have a data class, or we can just decompile this bytecode and see what we get. So, are you ready for this? We get all of that. We have everything that we had before, plus some new parts. So let's just look at the new things. We have this component 1 and component 2 that returns each of the fields, flavor and icing. These are used for destructuring class declarations, which I'll elaborate on in a bit. Just note at this point, they return the properties, flavor and icing. And then we have a copy function, actually kind of two copy functions. There is a synthetic bridge method that goes along with it that uses masks to allow you to pass in different things depending on how you want to make a copy, if you want to change anything. So what this means for us is, say we have a cupcake, we can either just make a direct exact copy. We could also say that we don't want icing on this copy, because maybe someone doesn't like icing. We could also make a copy and change the flavor, but keep the icing. And then we could also make a copy and change the flavor and the icing. And then if there was more properties, we could do this in any combination that we wanted. Also notice here that in Kotlin, we can use named parameters, which can be really handy. All right, so moving on with this data class. We also have toString, which just clearly prints out the class and the properties. And then hash code and equals that do as you might anticipate. So we get all of that from just 4 lines of code. And those 4 lines could really be made 1 line. And this is part of the thing, one of the things, this boilerplate reduction, that I really enjoy about Kotlin. Now, we saw those components, and I said I mentioned this word, destructuring class declarations. So let's look at that real quick. These were the component 1 and the component 2 that we saw before that returns the 2 properties. when you have a data class, there's a component 1, component 2, component 3, so on, for each of the public properties. So, because of these, we can do destruction class declaration, which is this here. We can assign two or however many properties you have, variables, from the object at the same time. And then you can use them just like any other variables. So what does this look like when we decompile the bytecode? What is this doing? And it's not real tricky. We're just assigning the two variables on two different lines. Flavor is being assigned from cupcake.component1, and icing is from cupcake.component2. So nothing too tricky under the covers. And then we just do the rest the same, use them as you would anything else. Where this can be handy is in multiple different places. One place might be a loop. Here we're iterating over a list of cupcakes, breaking it down into the parts automatically, into the flavor and icing, and then doing something with it. In this case, just printing it out. And then when you look at the results of this loop, it has an iterator, and inside the loop, it's just using that component 1 and that component 2 to automatically get those parts for us. Another thing that's closely tied to classes are companion objects. In Kotlin, we don't have static variables that we can use. So one way we can get that functionality is through companion objects. How we do that is nested inside our class. We create this companion object, and we can put our variables there. So we're making variables for our couple different flavors. We have vanilla and chocolate. You can add whatever else you need. But here we're just doing the two. Then when we decompile this, we get this. There's kind of two parts here. We have our private static final variables that have these values, as well as a reference to the companion object. And then in the companion object, we have getters for these variables. Now, that might not be exactly what you were looking for when you created these static variables, but there is a way to get around this. We don't need those getters and setters, so let's make it so we don't have them. Since we're working with strings, you can do this with string or variables. You can add this const. We're using a constant. That's really what we're creating here. So after we add this keyword, const, here's what we get. What we want. Instead of having those getters and setters in our companion object, we have these public static final variables that we can just access without that extra method call. Okay, so we've seen how we can take care of boilerplate using data classes. What about the null safety I mentioned? It's one of the biggest things that we hear about when we talk about Kotlin. We already saw how it checks parameters just for extra safety, but what about the force null checks that I mentioned, and what are our options for those? In Kotlin, you notate that something is nullable with a question mark. So this variable ice cream could be null, it could have ice cream in it. We don't know. So this nullable value, if we don't check for null before we call something on it or use it someplace that you can't have null, we get a compiler error. So we can't compile this one, so we're also not going to decompile it. What are our options for checking it? Now, if you're used to programming in Java, you might do it this way. If the ice cream is not null, then call flavor on it, get the flavor. And then we're also including an else here. Otherwise, let's return null. Now, this works, but Kotlin has some handy tricks for other ways that we can do it. One is to use the safe call operator. That's this question mark after ice cream before we call .flavor on it. What this is going to do is it is going to call flavor if ice cream is not null and return null otherwise. Another way to demonstrate this is to decompile the bytecode. And we get this. It's a ternary operator. It's checking if ice cream is not null and returning the flavor if it's not null and null otherwise. It's pretty short and simple, and it's oftentimes much more cleaner than wrapping a whole bunch of things in if not null blocks. Another option, if you particularly love getting errors or are overly confident, is the double bang operator. Most of the time you do not want to use this. There are some very few cases that it might make sense. But by doing this, it will throw an error if the variable is null and return call the operation and return the value otherwise. So what exactly does this look like? What is this doing? There's the double bang operator. Okay, so it is checking if ice cream is null, explicitly throwing an error if it is null, and then if an error hasn't been thrown, it does continue, then we're returning the flavor. All right, you can combine the null safe operator with different things. One is the Elvis operator. That's this question mark with the colon. What this is saying is if the ice cream and the flavor is not null, then return that. Otherwise, return this, say, default value chocolate chip, because I want chocolate chip ice cream. If there's no other ice cream, like, find me some chocolate chip ice cream. What this is doing is here we're checking if ice cream is null, making sure the flavor is not null, and returning that. If that's not there to return, then we're returning the default value, chocolate chip. Now, you can also use the combination of the null safe operator with some higher order functions to create null safe scoping. Here, we're using the null safe operator with let. And then we're passing it a block, a lambda, and inside that lambda, we're assigning the not null value to this variable we've named not null ice cream, and then calling something on it, because in that block, it's not going to be null. Now, we can clean this up a bit. We don't have to name that variable. If we don't name it, it'll default to a variable named it. Because we're passing in a lambda as the last parameter of a function, we can put it outside of those parentheses and remove those variables, or those parentheses. And then as another option, we can use function reference. All of these are essentially the same exact thing. When we decompile this, we have our check if ice cream is not null, assigning it to a variable, and calling get flavor on it. Otherwise, we're returning null, essentially. Basically the same thing as we saw in the other examples. So that let gave us a taste of what it is to use a higher order function, what it means to use a lambda. How might we build one of these? So let's make a pie. This make pie function takes in a lambda to prepare the filling, because we have some preparation we need to do before we handle the filling. We got to make the crust, and then we'll prepare the filling and put it in the pie, and then we'll bake the pie. To say that we want to pass in a function into another function, we have our variable name, prepare filling. We have our inputs, the type of the function. So we have our inputs to the function, which here we're not including any inputs. It's just empty parentheses. An arrow, and then the return type of the function. And then inside the function, we can just call it the same way that we would any other function. We just call prepare filling. When we decompile it, that parameter turns into a function 0 object. This function interface has one method on it called invoke. The 0 corresponds to the number of parameters. Remember, we didn't include any, so it's a 0. If we had included one parameter, then it would have been function 1, 2 parameters, function 2, and so on. We have our check that the parameter is not null. We've seen that before. We're making the crust. And then the next line is what we want to look at right now. It's doing prepare filling and then calling .invoke on it in order to perform that operation. And then the rest is what we've already seen. Cool. So how might we call this function? Just like we did with let, we're going to pass it in using curly braces. So we have our function, make pi, and then the lambda that we're passing in is encapsulated in curly braces. And then in here, we're gonna take some apples, we're gonna cut them up, add some spices, and turn it all into filling. Cool. And that's gonna return filling, that to filling. So let's decompile this, see what happens. And it kind of looks that we copied and pasted that code in. The reason that is when we created this method, we included this inline keyword. Let also has that inline keyword, and what that means is when this is used, the compiler is going to insert essentially the body of the function that we're passing in into where it's being used in the generated bytecode. And we saw evidence of that with let, and we see evidence of that here. It's just inserting what we were passing in into where it's being used. So what would it look like if we did not make it inline? The only difference here is that we removed that inline keyword from the declaration. So what happens in this case? Here's what we have. And that looks kind of weird. We have null.instance. Now, to understand this one, we're going to look at the bytecode. We're going to step through it step by step so it doesn't look that scary. So, starting at the top. Oh, it's really close to the top. I hope you can see that. We have our final class. It's called lambdas kt, which was the name of the file, make apple pie, which was the name of our function, and then 1. It extends lambda, and it implements function 0. Makes sense. Then we have our invoke function. It returns filling, it's non-null. Okay, this isn't too bad. We have all these line numbers. These are, as far as I know, mostly used for debugging, so when you're walking through, this is how it's able to point you to where it is in your Kotlin code that you're stepping through. And then we have the body of our function. This is the stuff that we care about. So we're creating our apples, we're cutting it, then adding spices, creating the filling, and then essentially returning it. That all makes sense. That's what we wrote. Another thing that I want to point out is this public final static instance. This was what that Java code was trying to reference when we saw that null.instance. It is initialized in the class init and assigned to that instance variable. Now, the decompiler might emit inner classes like this one. This is only internal to the bytecode when it's decompiling for brevity. So then in our Java, it didn't have that class to reference, so it put that null there. There are a couple times, such as this, that you will get some funky, unexpected things when you are decompiling Kotlin bytecode into Java. Through doing this exercise, we now can better understand the difference between inline and not inline functions. We know that when it's not inline, it creates that function object, it initializes it for us to use later on. Where with the inline function, it's generating that code to insert of the body of the function for us. So one, the code is a little bit longer, it's bigger. Another, there is an additional object being created. So we've learned about the build pipeline for Kotlin, how it's compiled into bytecode for the JVM or anything else that uses bytecode to run. We've also looked at how we can take advantage of that to help us understand some Kotlin language features, as well as understand some of the performance or size or method count implications of that. Now, we just looked at data classes and companion objects, destruction class declarations, lambdas, null safety. There's a whole bunch of other things that you could try to explore using this. Still, not an extensive list, but it's a lot of fun, and I'd encourage you to check it out. Whether you're doing it just for fun to help you understand some of the Kotlin language features that you're learning, or to understand those performance or size implications. It can help you make trade-off decisions. If there's two ways to do something, and one might be better for your use case after you've looked at the specifics of it. So, if you're ready to hop on board with Kotlin, and you haven't started yet, in addition to being able to convert your Kotlin bytecode into Java, you can also take your Java files and just straight up convert them to Kotlin. IntelliJ Android Studio has this tool for you as well. To do that, if you have your Java file, you can go to code, convert Java file to Kotlin file, or just search that action. And then there you go. You have your Kotlin file. Now, most of the time, you don't need to do anything to get it to just work, but I encourage you to watch out for those double bang operators, as that's where your null pointer exceptions are going to come from. And I'm assuming that when you're converting to Kotlin, those are one of the things that you are trying to avoid. We've had a lot of success with incrementally converting existing Java projects into Kotlin because it is so interoperable. That's one of the main focuses with creating the language. So we've been able to take just one file at a time in a project, convert them over, and just add Kotlin as we go. You don't have to make it a huge thing to convert the entire project all at once. Just step through as you're learning the language. And I'd like to thank you all for coming. I will be around after this for questions. I know the conference is basically over, so if you don't catch me after this, you can also catch me online. I'd love to continue having conversations for this. And again, I appreciate you sticking around to the end of the conference to see this talk. And I will talk to you all after this. Thank you.